These are the most frequently asked questions from Algebra 2, Section 2-4, Day 2. The first one I thought people might ask about was number 31. It says a meal plan lets students buy $20 meal cards, and each meal card lasts about 8 days. So the first thing that you want to do is try to figure out, all right, if it's lasting about 8 days, how much are they really spending each day? And when you do that, you take 20 and divide it by 8, and that comes out to $2.50 for each day. So what's really happening here is they're starting off with their $20 meal card, and then they're using $2.50 for each day that they're eating. And yeah, I can use D for days or X, and I'm sure most of you would appreciate it if I just used an X there. So you can think about this as, graphing an X and Y as you go through this problem. And then it said we're supposed to make a graph to represent that situation. So then that is exactly what we do. In number 31, what we would want to do is think, okay, well, if they hadn't spent any money yet, so 0 days, they would have all $20. And then if the Y is 0, well, how does that work? Well, again, you can think of it just as putting a 0 in right in here. And pretty soon you realize, well, that's going to have to be an 8 for the other side to come out to be a 0. So 0, 20, and 8, 0 are what I want to graph here. So I'm going to go by intervals of 2 to fit this right up here. And then I'll just go by ones for the days right here. And anything on that line will be something that they will be able to spend. Now, pretty obviously, if there's a certain amount they get charged for each meal, but we're just going to say anything along that line would work and would be a graph. And yeah, we should probably, make sure that we're putting on there that this is meal cards, and this is days, and this is money. Make sure we have all those nice labels on there. The next one I thought people might ask about was 41. Apologize, my cold is still getting the best of me here. This is in standard form except for the fact that, we have that 2 in the denominator. So easiest thing probably for people to do is just get rid of that right away and just multiply the entire equation by 2. And then you can go after the zeros a little bit easier. And that's not to say you can't do it with a fraction in there, because you can, but I know that most people would prefer not to work with fractions all the way through. So if x is 0, that means basically we don't need to worry about that. We just need to figure out what would we put in this position to get a -6, and that would just be a 2. However, in the next case, if we're going to put a 0 in for y, now this is gone. And so really most people will think of this as dividing both sides by 4 to solve it. So we'll get -6/4, which is -3/2. And then we're just going to graph, and I think I'm just going to go by ones. So 0, 2, and -1.5, 0, right there. And again, you could use the slope here to try and make things a little bit easier for you when you're graphing if you wanted to. I think that's probably enough space between the two of them for us to get a feel for it. So to go from one spot to the next, we're going to go up 2 units and over 1.5. So up 2 units and over 1.5, up 2 units over 1.5. So you can always use that slope to spread those points out a little bit farther so you get a little better look at what's going on. So there's the graph for that equation. In number 42, it says write an equation of a line through each pair of points using point slope form. We know whatever form we're using, we're going to have to find the slope. So the first thing I thought of when I looked at 42 was we need that common denominator again. So I would multiply this first fraction by 3 on the top and the bottom, and this second one by 2 on the top and the bottom to get this all in sixths. So this first will be 9/6, and then negative 3/6. And the second point would now be negative 4/6 and 2/6. And again, you can see if you reduce those, you get right back to the original. So for the slope, we need 2/6 minus 2/6 minus a negative 3/6 divided by negative 4/6 minus 9/6. So 2/6 minus a negative 3/6 will be 2/6 plus 3/6, which is 5/6, divided by negative 4/6 minus 9/6 will be a negative 13/6. And then we don't divide fractions, we multiply by the reciprocal. And very nicely here, these 6's are going to cross reduce, and we get negative 5/13. And then what we need to do is just pick one of those two fractions and write this in point slope form. I think I'm just going to go with the first one right here. So y plus 1/2, because minus a negative will make that a plus, equals negative 5/13 times x minus 3/2. And because it said leave it in point slope form, that's exactly what I'm going to do. I'm not going to try and clean that up at all. So there's number 42. The next one I thought people just might have a little trouble with, mostly because the picture was just so small in your book, was writing an equation for the line shown here. And in this case, as long as we can make out that slope easy enough to count it, and we can clearly see the y-intercept, well then that's what we want to use. So I'm taking a look at this drawing and I'm seeing the 1, 2, 3, my y-intercept, which is of course b, is going to equal 3. And then what I want to do is think about this point down here and this point, and how do you get there? How do you get from the left point to the right point? Well, we'd have to go up 1, 2, 3 units, and over 1, 2, 3, 4 units. So rise over 1 would be 3/4, which is our slope. Now, you stop and think about it a minute. It makes sense because this line is going up. It should have a positive slope. So y equals 3/4 x plus 3. And there's a couple bullets here to try to help you if you're stuck. You know, what do you know from the graph? We can see the y-intercept, and we can also see and count the slope. And then which form of the equation of a line could you use with the information you have? As long as we can pick out that intercept and we can count that slope, we sure can use slope-intercept form for number 45. Okay, now the next one that I thought anybody would ask for was number 54. And this one says, write the point slope form of the line that passes through A at negative 312 and B at 9, negative 4, and use point 8 in the equation. So you're not allowed to pick which one you want at this point. You're supposed to use the ones they give you. The first thing you do is find the slope. So we're going to need 12 minus negative 4 over negative 3 minus 9. Well, minus a negative is a plus, so there's 16. And then 4 divides into both of these. So we get negative 4/3 for our slope. And it said use point A, so we don't have a choice. We're going to use negative 312. So it will be y minus 12 equals negative 4/3 times x plus 3. So there's part A, where we just have that in point slope form. Now for B, we're supposed to take that and write the point slope form of the same line using point B in the equation. So that one would be y plus 4 equals negative 4/3 times x minus 9, just using the different point there, point B. And then C says, rewrite each equation in standard form, and what do you notice? Well, of course, what's going to happen? We already know what's going to happen. They're going to be the same line, but we're supposed to go through the motions and make sure that happens. So for the red one, I would have y minus 12 equals negative 4/3 x minus 4. And then I would go ahead and move the 12 over just to get all of our constants on one side. So y equals negative 4/3 x, and then we would have plus 8. Well, now I want to get my x over to the other side, so I would add 4/3 x to both sides. And you could say at this point, I would multiply everything by 3 first. Do that, whatever you want to do, as long as we can get to the same endpoint here, which for me now would be multiplying everything by 3. So every term in the entire equation gets multiplied by the 3. And I get that for my standard form. Now I'll go after the green one. Y plus 4 equals negative 4/3 x plus 36/3, which is going to be 12. And then move the 4 over, and y equals negative 4/3 x plus 8 should look real familiar. And then I'll go ahead and add my 4/3 of x to both sides. So I have 4/3 x plus y equals 8. And last but not least, multiply every term in the equation by 3. 4x plus 3y equals 24. And they are exactly the same. So what do we notice? They are the same. And I believe that was the last one that I thought anybody would add. Oh, no, got another one here. Number 56. Write an equation for each line, then graph the line. So in number 56, they're giving us the slope and they're giving us a point. So we want to go ahead and use point-slope formula. This will be y minus 0 equals 5, 6 times x plus 4. So y equals 5, 6x plus 26, which would reduce to 10/3. Now, if I were going to graph this, I would definitely just go by the original information and say, okay, it's supposed to go through negative 4, 0. 1, 2, 3, 4. There it is right there, going by ones. And then go up 5 and over 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And connect up those 2 points. And again, that's because our fraction for our b value is not a real pleasant one. 3 1/3 is not something real accurate to graph. So you'd be better off just using the initial information for the graph on that one. And that is it for the most frequently asked questions for section 2-4, day 2.